All right, shall we start? So, yeah, hi. Today we're talking about ECS, yeah. So ECS is mostly useful for things like system mods, not really food mods. So if you're here for that, I'm sorry, it's not really that related. But if you're interested in making, let's say, an appliance mod or something, this is actually quite relevant, even though you may not actually be making a system itself, because of the components and stuff that's being used, and we'll talk about all that. All right. So let's begin. So first of all, what is ECS? Right. So ECS is actually called anti-component system. So as you would guess, there were three parts to it. First is entity, components, and systems. So for entities, it's very similar to game objects. I'm not sure how many of you have actually done Unity. Do you have any command say in the chat or anything? Have you ever done Unity or anything related to game object space? All right, but I guess you haven't done ECS itself. You've done most like game objects, components, mono behavior, right? So this is actually related to game objects in some ways. It actually uses game objects later on in the thing, but that's related to views, which we'll talk about in the second part of the session. All right. So there's actually a link to it. Yep. So entities are very similar to game objects. They are actually like a thing. You can think of the object-oriented programming with a thing, right? Except that entities don't actually have any behavior to it. They are just a container. And what are they a container for? They're a container for components, right? So components are data structures. Effectively, like you can think of it as when you have your object-oriented programming, you have your age of your person, the name of the person, the address, these kind of things. So it's all data, right? And systems pick up on all this data and do game logic on it. Right? So moving on, this is actually an image from in-game. We have this tool called PlateUp Explorer. We'll talk about it later. Effectively, entities are not really um, tangible in a sense, right? So even though we have two players here and two customers, right? These are not actually entities, right? And why not? Because those are actually game objects, right? It's effectively related. It looks tangible. You can think of it as entities, right? But they're not actually entities, and we'll talk more about it later. Um, each entity has components to it, right? That make up the data and describes what the entity is. So take for example this player character. It has a tool user. It can hold items. It's an interactor, right? And it is a player because the player has data, right? So when we look into player data component, we can see its ID, index, speed, and input source. Input source effectively describing which computer the player comes from. So these are all data. All right. So you can see in this, with all this data, right, we're picking up in a system. This is effectively what a system is. We'll talk more about it. It's very large, effectively, right? So this is a create bedroom system in the base game itself. Um, I assume all of you have went through the course yesterday, right? IL Spy and installing IL Spy, installing Visual Studio and all those. So we're really be using these two today, Visual Studio and IL Spy. Right, effectively a decompiler. So this is actually taken from decompiler, is the base game system. Right? So we'll talk more about this initialize function first. In the initialize function, right, you actually pick up on entity queries. So what is an entity query? Right? Entity query is just to get all entities that match the given conditions. So the given conditions are actually like what components does the entity have, right? So if it's in all, then all entities must have these components. You can also set any, which means that as long as entity matches one of the components, it will be returned. And if it's none, then the entity will not be returned. All right, if there's any of the components. So far, any questions? Okay, now move on. So for components, right, there's a PlateUp convention where components start with C. And if there's a singleton, it starts with an S. So what does a singleton mean, right? A singleton is a component that only appears once. So it's a PlateUp convention. It's not necessary to follow it, but it's good to follow it when you're within the PlateUp ecosystem. So that anyone who uses your mod knows what it does, right? So if you go back here, you can see this is a C player component and a C position component, right? These are all components that appear multiple times because there are more than one player and there's more than one position in the game. So that's why it's a C, right? There's also common singleton components here like S day, which describes a day, S layout, which is a marker for the restaurant layout, these kinds of things, right? So we can try some queries first, right? So there's this mock player explorer in the workshop. I made it. So you want to go to the workshop, right? And search up for PlateUp Explorer. So let me change my screen here. Go to the workshop. Right. So this is actually the mod. When you click subscribe on it, right, it brings up these things. I'm sure you know, like you've done it before. So that's what you would do. You would just subscribe to all of it, and you can use this in game. Right. So I'm gonna install it in game now, and then we're gonna play around a bit. Right. Launching the game. Windows to play it up. Yep. 1 second. I'm waiting for the game to launch. There we go. Right. So when we're in here, right? I'm gonna go into a restaurant so we can play around with actually what most people will be doing with systems, which is usually in a restaurant. So in this restaurant, right, we have we use Control Shift T to open up this kitchen lib menu, right? If you have kitchen lib installed, this menu is available. The PlateUp Explorer adds these two things. So entity query, GDOs. Systems is not really that much used, but yeah, it's a thing. So for entity query, you can scroll through this list. Actually, PlateUp has a lot of components, right? So these are all components. It's pretty large, right? There's a lot of components. So if we look at just now what we are saying, sday, right? You can search for sday. You can do all, any, or none, right? If you don't find the sday component, so you can use either all or any, right? So if it's all, I will get an entity returned, right? And I can use this to take a look at sday itself. So in sday, the day now is actually 0, right? Even though it has day 1 here. There's a reason to it, and I won't get into it, but this is what it is. So when you start the day, right, and get the day sday back, you see a day becomes 1, right? This incrementing of day is all done by systems. So this is what effectively um, ECS actually is, right? So we have an entity that contains this sday component, and the sday component stores a day, and this day is incremented by a system. So if you go back right now, let's quit out. There's also other things you can do, right? So you can do things like find all appliances here, right? So I can search for C appliance, for example. and it gives me all the appliances that are present right now. So this is how you actually use the system. You actually make an entity query. The reason we made this tool is because you can't actually see the entities. So this is a tool used in game, but it's not actually how you would do it in code, right? So if you want to go back to the game now, to the code now, right? You can see this thing. Let me go to the PowerPoint presentation. There. So this is how you would do it actually in code, right? What we did earlier was to find all appliances, right? So you would do appliances equals get entity query type of appliance, and it will return you all the appliances. Right. Yeah. So blueprints are appliances as well. So that's how it works in the game. That one is for you to discover later on. It's not really something to describe specifically the nuances of the entities in PlateUp. Right. So for entity queries, right, you can see that you just give it a entity query variable, and in the system you can do get entity query. By default, this is using all. So an entity must contain C player and C position in order to be written. All right, same for customers. You can do customers equals get entity query type of customer and position. So any entity with customer and position will be written. All right. Now let's say you want to do both players and customers. You need to use entity query description, which is actually a combination of multiple um, queries in a sense, right? Or multiple like conditions. So we use any here. Yes. So position actually C position actually contains quite a lot of things. It actually contains the position and rotation of the character. That's mostly what it is, but there's also other things, and I forget what it is, but you can search it later. Actually, do you want to see in game right now? So we can do this. Oops. Change windows. Mm. So it's actually used for quite a lot of things, right? So the position actually used to track where the player is. I wouldn't say it's necessarily used to determine what they can interact with, even though the system would actually use it, right? It's actually just a position. So let's say you know how we have the Halloween event going ongoing, right? And the players swap positions. So you would actually set the position of the character to a new position. That's how you would teleport the player around. It's really just data. Yeah. Yes. Appliances, workstations, effectively everything that has a position or world uses C position. Right? You can think of it as anything that has a position orientation. Uses C position in PlateUp. That's how it works. Yes, that as well. So ghost objects like chairs are also appliances. It's a weird thing like that. Right? So actually a lot of appliances in PlateUp. Blueprints are appliances. Trees outside are appliances, even though it's a tree. So we'll get into that later. Appliances are not just game objects. So effectively, you can think of everything in PlateUp as ECS, right? So putting game objects aside first, PlateUp is entirely actually in ECS. It actually has no. If we did not have to display to a screen, the PlateUp game logic is all in ECS. There is no game objects involved. Yep. So it's actually all in IL Spy. We can look around it later, but for now we just get into the concept first. All right. So going back to this, right? Players and customers, right? you can look for both of them by using any. So if an entity has both any C player or C customer, right, either one of it, and it has C position, then return both of it. So this is actually a combination of the top two queries, for example, right? PlateUp also has a helper, which is new query helper, and effectively it's the same thing. It's just different representation, but effectively that is what it actually helps you extend entity queries easier. So any just means that it has to contain at least one of these. So if let's say you have 5 things in here, you have player, customer, appliances, right? Or like more than one. So like 3 things. I don't know. Player, appliances, customers, they all have C position, right? As long as one of it is contained within this as long as the entity has one of it, any one of it, it'll be returned. It will no. So it can do have 2 or more. So it's at least one. So if let's say hmm, what example would that be? I could also do any C player, C customer, and C position, right? And it will return players, customers, and everything else as a position. Effectively, yes. So it is a filter. Um, you can think of it as a filter of all entities. It's not really how it works, but yeah, that's what it is. Right. So effectively, you can get any entity combination that you want using these rules. Right. So let me just close this for now. So there's different. Oops. So sorry about that. So there's actually different types of components, right? So what we've been looking at just now, right, were all data components, right? Really things that store data, store single bits of data, right? And you notice that a player cannot have more than one position, right? So there's only one C position allowed on the player because it is a I component data, right? So it's defined as I component is data defined as having how to say unique data for it for each entity. There's also this thing called I shared component data, which is shared across multiple entities, right? So if you have let's say you have all appliances, right, and that a large part of the appliances have let's say a color, right, and they all have the same color, let's say, then you would do it as an I shared component data. This is actually rarely used because most things are actually unique, right? We have actually very few instances of repeat things like this, but it is there. So if at least it's a optimization that you can use, and you can see more in the IL spy and whatever when you want to. Yeah, this is actually rarely used, but I'm just touching over it so you at least know it's there. Yeah. The fields in a data component, right, must be what are called blittable. Right? Blittable just means that there is 2 types of data. One is managed, one is unmanaged. Right? Blittable means that there is no need for any sort of conversion when you go between managed and unmanaged. So things like your native variables, integers, floats, doubles, right? These things have the same representation in both managed and unmanaged data. So all these can be used in I component data, or if any sort of like component actually. Yeah, so both I data I component data and I shared component data. So you might think I want to represent a string, right? In my component. How can I do that? So there's something actually called a native byte array, right? Basically a native array. A native what's it called again? Native string, I believe. Yeah, it's called a native string. So if it is a unity collection that is a blittable form of a string, you have to use that within components. You cannot use strings because it is not blittable. right? So just something to note, you'll rarely run across this issue unless you want to do something really weird, right? There's also something called buffer components. So if you have more than one thing, more than one of that thing in the entity, you might want to use a buffer component, right? So a buffer component, if a day is allowed, you have multiple times of it within the same entity, but you cannot just add it like you would a buffer, a normal component data. You have to create a buffer that contains all of these buffer components, right? So this is actually also rarely used, to be honest. It just exists. So things like customer group that has many customers, right? You might want to use a buffer within the customer group entity to contain all of its customers, to contain references to all of its customers. Then you also have layouts with many tiles. So like a restaurant is 16 by 12 and you have that many tiles. Yeah. So yes, you could do that, right? You could also have individual entities as Nova described, right? It's just easier to grab it. Let's say you have a system that does like you know how when you serve an item to a group, right? Yes. So that's actually one example of it. But I'll go back to my so let's say you have the group, right? And you serve an item to them. You want to be able to look through all of the customers that are part of that group. So when you have um a group like this and you want to determine whether the order is part of that group, you cannot just search for all customers because you don't know which group they came from, right? So you need to have a group entity that contains references to all those customers because it's through that specific group. Oysters is different. So that's actually part of game data objects, which we'll cover tomorrow. Um, it's it's not an entity effectively. So when you combine a oyster onto an oyster plate, it changes a different item. It's slightly different. In the case that you mentioned, right? Yes, chairs belong to a table will be stored in a buffer. Right? So if it's something that belongs to a larger group, so you can think of it as a collection of things, effectively. All right. Okay. I'll just move on first so we can like catch up, and because there's actually more to cover later, including like views and things. So we'll move on first. Uh, so what you mentioned earlier, right? Monica, was about this GDOs. So we'll cover more of that tomorrow in the kitchen lab workshop because that's how you create game data objects. Um, systems actually do tie into it a little bit. So when you create appliance, it has to have an I appliance property, I item property, I customer property, depending on what it is, right? Let's say you define a specific component that is always present on that appliance. You have to use a I appliance property in addition to a I component property. If it is an extension of I component property, I component data. We'll go through the code later. All right. We just want to cover the concepts so that when you look at the code, you actually know what's going on. Yep. So this is actually GDO thing will be covered more tomorrow. And I won't touch on it much, just that know it systems actually tie into it. Right? So let's make some components. Right? Nova, do you want to take over or do you want me to do it?
I can take over for this.
All right.
Give me a moment to open the PowerPoint real quick. So a general basis of components is the I-component data interface. I'm sure that was described earlier. This is just a small demo as to a few custom components you could create. This one in particular is structured as a singleton which will start with S, whereas individual components start with C. To be noted that if we are without kitchen at the start of our namespace, we would need imod component. This is just because of how PlateUp captures our components. Definitely a lot of benefits to having the kitchen prefix, yep. So we have data in our components, but there are some types that aren't mentioned in our PlateUp list. That's a good question, and a singleton means there's only going to be a single instance of an entity with that component. Or there should only be, really. Say more, something like the UI. The UI will hopefully only exist once over. Whereas the booking desk is an appliance and can exist multiple times. The C and S are merely a suggested naming convention though, so there's nothing truly stopping us from creating more other than our own advisory. They do check that, and I do not quite know the specifics of that, but that is more checking if any of it exists. Lot to the shop system. So we have certain types that we cannot put into components like normal system.list. This goes for things such as strings as well, as they are not automatically converted. I do not know quite the specifics behind this, so I won't spew anything that I do not 100% understand. But I do believe it is serialization. That is a good mention, actually. That is the number of bytes that the object can contain. So the first list of ints is a 128-byte list of ints. And same goes for the string. To be noted, as I learned this the hard way, that these cannot be used in views, which will be covered later on. Buffers are very much so alike normal components in their structure, except they do require a set capacity. The capacity is an absolute value, not bytes. The value types you can put in are the same as any other component, though. I believe that covers creating components, unless you have anything you wish to add, Milo.
Yeah, so I'll add a few things. I'll just touch it up. It's actually mostly there. The internal buffer capacity, right? It's merely a suggestion. It's not actually a fixed value, right? You don't have to stick to 4. You can go to like 1, 2, 3, right? You can store anything less. You can store anything more than that. The internal buffer capacity, you can think of it as a pre-allocation of memory, right? It's just for optimization on the part of Unity. All right. So buffers, they don't actually have to be a fixed size. They can be they actually variable in size, as if they have a minimum amount of memory that you pre-allocate at the start. One more thing is for structs, right? For your regular iComponent data, you may not have any fields in it sometimes. Things that are just markers, right? So things like S layout, S is day first update, these kinds of things. They don't actually contain any fields. They're just marker for the entity. So when you look for a singleton, you can find it and all its data, except that it doesn't store any data by itself. All right. So to do that, right, you'll put struct layout. Layout kind is sequential, and the size is 1. Right. So it's like you want to do it on the thing. So there is struct.
I did not catch that.
Yeah, size equals 1. Once again, I'll just type it for you. Layout kind dot sequential. Right, so you would do that to as an attribute for the component itself. Right, this is just effectively it's not an empty thing, because a thing with no data doesn't make sense, right? So effectively you're giving it a small, very small size as just a marker that sits on the entity, even though it doesn't contain any data. Right, it just takes up a certain amount of memory. So this is the kind of components that you actually use, and I think that actually covers all of it, at least all the common ones. There are some very abnormal ones, and you won't actually see them at all, really. All right. So I guess you can move on to the system itself, right? So I'm gonna go back to slides for a moment. I'm just gonna show you a few things, and then we'll just make a system, right? We'll just do with some examples. So as you saw earlier, the structure of the system, we covered the onInitialize where you set the entity queries. You can also do other things like setting when the system should update. That we'll cover in a moment. And any other one-time setup, which is like think of it as storing a list of positions that you want to check. Right? Usually you don't store any data in the system itself. Right? But things that are just arrays of things you're going to check, not actually entity data, you can store in the system. There's also on update, which runs once every frame, right? And that's where you will update the entity itself. All the components of the entity, you will access it using the entity query and update it. So we'll show you how that's done. Right? This is a special type of system. It's called an interaction system. Right? This is a PlateUp specific thing. It actually extends off a regular system. So in the background, it is still a normal system, except that it's been extracted away. Right? So there's 2 types of methods here. One is called is possible. The other is called perform. Right? So you would check for because the system actually runs sequentially. Right? So when you order system A, B, C, D, all the systems will run. You need to decide which system the entity is being acted on by. Right? Because it can't be acted on by all the systems at once. If not, you would be storing a blueprint and picking a blueprint cabinet at the same time. That sort of thing. Right? So is possible is where you check whether the interaction is valid, and you will return true if it is possible. Otherwise, you return false and you skip the system. If it does pass and you do the interaction button, let's say you click on grab, right? Then the perform will actually do its action when the frame comes around, right? So let's move on to some examples. I will write out the system. So does anyone have any ideas of what's the kind of system they want to see? Hmm. Mm, yes. So you will do a check for this kind of thing. So you will effectively check if the table um item holder, that's how tables should hold the item, right? Actually, any appliance, counters, workstations, anything that holds the item has a C item holder component. You will check the item holder is filled. Hmm, let's see. Can you see it? Cool. So let me know if you have any kind of system you want to see. For now, I'll just do an example system, right? So let's say I have a so when you start any system, it's actually a generic system base. Okay, so let's try this generic system base. All systems in PlateUp are generic system based at its core, right? It contains a lot of helper functions, so to speak. Like get entity query was one of it, right? And you can get the occupant of a tile, so you can set in a position of a tile and get the entity that comes out of it, right? What entity is at that tile, for example. So it has a lot of helpers that you can use here, and I'll leave it to you go and explore it, right? But for now, we'll just do something more simple. That is so like this. So you would do a initialize, right? And here I would set up all my entity queries. So let's say an entity query for player, right? So I will get all players as I did earlier. Inside here, you would do players equals get entity query type of C player, right? So this will get all players. However, this entity query should also contain everything that I want to use in the system. So let's say this system is supposed to change the player color, right? I also need to put in type of C player color. Anything that I will be using has to be in this entity query. It won't show you an error. Actually, if you do it in Unity itself, it will. But because we're doing all in code, like this separately as a mod, it doesn't actually throw you any errors. But it's nice to know, right? And it's also a good convention to have it in the entity query itself. So now I'm going to on update, right? PlateUp actually uses jobs in the base game code, but we can't use jobs for mods. So we have to do it using regular for loops. So the way you would do it is you would do a native array and grab the component out, right? So let's say I want the entity. So I would do entity, right? And then I have a entities array, and I would use the query players dot to entity array to get the entity array. Inside here, we determine like what kind of scope this native array has. Because we are only doing it in this one frame, we just do allocated temporary. Right? Same for the component. Instead, I will do two component data array to grab the component out. So I can do C player color, for example, because I want the player color. So in here, I will do for integer I equals 0, I less than entity dot length I plus plus, right? This is if any looping over. So yes, correct. So I didn't explain this earlier. Using here is important because these native arrays, they need to dispose of, right? They are I disposable. If you didn't have this, you would instead need to do this. So you would do entities dot dispose at the end when you're done using it, right? So I will do, let's say, colors dot dispose, right? You can do this. You can do either this or dispose of it manually. Right. So using that is also fine. All right. So like putting it as a is a different version of your syntax, but that's it. All right. So in here, I will look through because these are actually zipped together, so they're actually the same length. So you can do this for loop and look through multiple of them. You can do entity equals to entity I. So you can grab the entity out. All right, and then I'll also grab the C player color. So these components are actually for the same entity. Right, if you have more than one, let's say a C player here, it'll be for the same entity. So you don't worry about the sorting of it. So let's say I want to change the player color. I want to increase the player color by a certain hue, right? So let's say I would do color dot let's say we do RGB to I do this instead. So I need to do Unity color. So no, I need to use Unity with oops color from Unity engine. Unit dot RGB to HSV. I'll use this color dot color. Right? And then it returns me a out float HSV. So I will do out floats H. Right? So now I'm grabbing the color from the player. This is how you read values out. You just read it out as a struct. Then let's say I want to do H plus equals 0.05. Why not? Right? And then I'll set it back. Because it is a struct, so it is not actually passed by reference. So all these values are not referenced. They are just if I this color, if I modify it, I have to set it back into the entity. Otherwise, it wouldn't change. So I would do set entity color. This set is actually a part of a generic system base. So it's actually a helper in there. If not, you have to use the entity manager itself. PlateUp has a lot of these helpers to make sure that you manage all these components safely. Otherwise, it will throw you errors. So this system will just every frame read out the play color, get the hue saturation and value of it, and after it would add it. Oh, my bad. So I need to actually set it back, right? So I need to do color dot HSV to RGB. Right, convert it back. So I would do this color dot color equals to this because again it's a struct, so changing the value wouldn't affect it. Then I'll do HSV. Right, I'm just setting it back in. So every frame it will read out the color, increment the hue, set it back to this, and because changing this value doesn't update the entity, I need to set it back to the entity. So if you notice something here, my namespace doesn't have kitchen. My system also doesn't have iMod system. Right? So if I were to now build this mod and run it in game, it wouldn't do anything because the game doesn't actually doesn't actually initialize the system or like instantiate the system and add it to the world. So I need to do iMod system, or I will need to kitchen. All right. So could you make a helper function to help convert the RGB to HSV and then back to HSV? Yes, you can do that. You could do something like this. So if I do private increase hue. So it return a color, let's say, right? Color increase hue. So I would take in a color, original color, and then it will increment the hue and then return it back. Okay. Load amounts, let's say. So I could pick all these, put it in here, and return this. Right? Similarly, in here, all I do is to increase hue by X amount. Alternatively, you can just set the variable inside, but I wouldn't do that. So the thing about doing such a thing as in like incrementing here, you actually rarely do it. All right, so you actually normally set a specific RGB value. In this case, cycling the hue like this is not something you normally do. So I wouldn't say it necessarily needs to be a util, but there are color utils all over. So things like materials, right? PlateUp has it's no so KitchenLib has its own material utils, but I'm sure they'll cover it more tomorrow. So material utils, right? It has a whole thing about materials, and then it has color everything inside of it. So you wouldn't worry too much about game data object material colors and whatnot. It's all handled within KitchenLib, and yeah, again that'll be covered more tomorrow. So if I run this now, in game, it will actually cycle the player's color, so the player will keep changing colors. That's an example of a system, right? But remember, this is a generic system base. So the reason why I'm mentioning this is because generic system base runs everywhere, right? It runs in the headquarters, it runs in the restaurant, it runs during practice mode, it runs during the day, it runs during the end of game screen when you lose and the newspaper appears, right? So to make sure that it runs during a specific time, let's say I only wanted to cycle during the day, right? I would need to make it a day system. So how a day system actually works, right? Is it actually does this require singleton for update as is daytime. So this is the basic component. When we mentioned earlier about marker components, things without data in it, this is what it means. If this as is daytime is present, right, the system will update during the day. All day systems will update when that component is present. So that's how it works. There's so many of it. You can look on the PlateUp wiki. We actually have a modding section of the wiki. You can take a look there. There's a lot of information about systems. So there's also a night system if you want to run it during prep phase, even though it's not night. Validly, it looks like daytime. But night is considered preparation phase in PlateUp. All right. So an example of what we did earlier was creating a marker, right? You can do something like public structs as my mod is active, right? So if your mod is active, let's say you want to have a toggle to your mod, right, allowing it to turn functionality on and off. You do something like this as well. So you can do I component data and I mod component. It's just good to do both of it, right? So you don't actually do this because I have kitchen in my namespace. But I will just do it anyways, just in case you forget it one day, right? And I can do things like that. So I'll do struct layout, sequential, size equals 1. Right? So this is a marker. It actually doesn't contain any data. So what if I want to have this data system run only when my mod is active? I have a toggle for my mod, right? I can do require singleton for update. And I do this. Now it will run during the day only if this component's around. So I can have another system where I can do public class toggle mod. That's it. And then I'll do a override. Okay. And then let's say I have a preference value, right, somewhere else. So don't worry about it too much right now. We'll cover that more in both KitchenLib and the preference system library mods later on. So I can do if preference value, right? So if I have a, let's say I want to toggle it. So I have a boolean here that says mod active. Okay. So if the mod is active, I want to set. So that's how you would create a singleton, right? That doesn't have any like it's just a marker. you would do set this. That's it. Right? Otherwise, if you want to destroy the entity, you will do clear. Right? As my mod is active. You will do something. So this would say that if your mod is active, it would enable this component and the system will run. Otherwise, it will clear the singleton and the system will not run during throughout the entire game, right? Unless you turn it on. So are there any questions? Right. So I'm just going to cover it right now, just a tiny bit. So you would have something like personally I've created like preference system manager, right? So I have a thing called this. So I will do this. Do I have it installed? I do not have it installed. So in order for the mod to appear or like the functions to appear within the your ID, right? You have to subscribe to the mod. So I'm going to quickly subscribe to the preference system. And then it should start appearing. Something like this. Do I have it here? Yes, I do now. So if I do preference system manager, right? This one way we do it. Preference system manager. There we go. And this is actually like a way that we can create preferences in PlateUp. So I won't delve too much into the specifics of this. But really what I can do is I can add an option, right? There is a Boolean option for whether my mod is active. And using this, I can read out the variable and set it. I can read out the variable in my system and determine whether I should turn on the system or not. Right? So active and stuff. What else do I have here? Active. I will start it false. Right? So something like that. And then I will register it. Register. Right? So if I added a preference here, what I can do instead is to, in my system, I would do this. Right? So it's not always gonna be toggling on and off. Really what it's gonna be doing is reading out the value. Right? Reading out the value of this preference and determining whether it should turn the system on or off. So it doesn't always have to be toggling back and forth like this, even though I set it, even though it's how it looks eventually, right? It's running every frame. If what I'm doing is every frame I'm checking the preference value, not toggling it on and off. Right? So there's more things you can do it for this, but I wouldn't go too much into detail of it. Right? So if it is how you make a system update when you want it to, right? I can disable the system if I want to, effectively. All right. So I'm going to quickly build this mod and make sure that it runs in and then show you that it actually functions. If not, yeah, I wouldn't actually worry too much about it because fairly you won't make in the system. So if any other mod ideas that you want to know about, or any systems that that you're unsure how to do based on this example, we can just write it down in chat and we can like talk about it later on. All right. Yes. So there's actually multiple templates that we use in our thing. So we have this, right? So let me just fix this. Right. So this is actually mod initializer. Because this is actually a standalone mod, right? It doesn't actually use KitchenLib. If you need to use KitchenLib, you would have base mod, right? So you would do base mod, like so, base mod, and that will it. Yeah, there's also game system base. If you even create a system, right? iMod system. So the mod initializer is actually not that important. The mod initializer, you can think of it as if really just sending up data before the game runs. It's a good idea to have. I'm not sure why it's not in the template, but we will figure it out soon. Yeah, you should have an iMod initializer in your mod, even though it's not actually necessary for system mod. Right, it's good for setup. Because you actually do it. You will do it quite a lot. Things like let's say you want to modify an appliance, right? So I'm going to cover it right now, even though it's Untitled object related, kind of. I will cover the component part of it because I don't think this will actually be covered much. So there's also this thing called game data, right? You can really get a lot of base game appliances. So this is how actually PlateUp Explorer gets it. If you want to play around with it, and see the data of a Untitled object in code, right? And what it will be like when you spawn it in. This is how you would do it. So I would do this appliance references. Let's say I want to get an appliance, right? I will do appliance reference dot let's say we do the booking desk, right? This is how you get the appliance out. Yeah, and then you can just do oops, try get right. And you can use this appliance and try and view the components within it if you want to play around before the next session. Yeah, so things like this you actually do in pre-inject and things. So in KitchenLab you would do it in it's a bit more complicated in KitchenLab. You have to use an event to do it because they actually tie this into an event. But I wouldn't worry too much about that right now. So things like this you would do in main and you would do in the iMod initializer effectively. So that is why you should have it. That's why I have it here as well. Right. No worries. I'll see you around. So yeah, if not, if there are no further questions, then we'll take a short break first, and then we'll move on to views, which is like a quick I think we'll just do a very short one because the views are actually a lot more complicated than that, and you'll probably have to do it as you do your mod. All right. So we'll take like 3 minutes for anyone to like go to the toilet, do whatever they need. All right. Mm. So can you describe what you mean by so template mod, we do have it. I'm not sure you're referring to it as a sandbox. So you're referring to something like spawning an entire like automation setup, for example. Oh, got it. So there is such a mod in the workshop. It doesn't actually display the blueprints. Yeah, it's called visible upgrade chains. It actually shows you what things upgrade into, but I'm not sure whether that's what you're referring to. If you're referring to a template that spawns in an automation setup, for example, right? I think Starflux did something recently. I forgot what it's called. There is a name for it. If it just spawns in a like a ghost of the automation setup that you can build on top of. Yeah, that. Uh, yeah, but I mean, you can always do something similar. There's no restriction saying that we can have one of such a mod in the workshop, right? There's like 5 ghost mode mods in the workshop right now, which is a little crazy, to be honest. They all function a bit differently, but it does exist. There's precedent for it, so I would just go ahead and do it anyways, to be honest. So from my understanding, the current mod in the workshop actually does what do you call it? It basically stores everything as was it JSON? It reads local data. Yeah. So if you have a way of doing it in game, let's say, I don't know, um something similar. I don't know. There's a different idea for it. I will just go ahead with it. Because you actually need to write out all the JSON and share it around in order for the other players to be able to view your setup. No, I don't believe they highlight what blueprints upgrade into each appliance. Although I can see that being a bit overwhelming on the UI side for the player. Right. Yep. So you can actually do that. I will actually do that in the main in the pre-inject, so you only run it one time during the setup of the game effectively. Right. So there is some nuance to it of when the upgrades are so called available, because they're actually present after pre-inject effectively. So you can do it in pre-inject, but you can't do it anywhere else. You can do it in post-activate, for example. So you would, if you want to do that, I would look around in the Discord to go to the dev general channel. You can just ask questions there as you work on the mod. You might want to give yourself the mod developer role as well in channels and roles. So we'll just get started with views, all right? So it'll be a quick one because I don't think we can cover everything about views in this session. There's already a lot of it. Views are really what you would think of as the PlateUp multiplayer implementation, right? So PlateUp has many ways of really displaying things, but it all runs through views. Uh, yes. So a view is effectively the game object side of PlateUp. That's where the hybrid ECS comes in. So PlateUp is actually a hybrid game. It's not purely ECS. So remember when we talked about entities earlier, right? These are actually not the same as whatever you see on the screen. Anything that you can see, anything you can hear, it's all game objects, right? It uses mono behavior in the background. So how are these two things linked is what we call a view, right? Views are really, really complicated. So there you go. That's what effectively how the view system in the background works. I wouldn't say you need to understand all of it. But that is why we cannot cover everything in one session. All right. So I'm going to skip over this because it's really not something you should. You just need to understand the scale of it, but you don't have to actually know it right now. Okay. So if any views, as I mentioned, are the game logic component of it, anything that you can see here, right? So particles, yes, this is the netcode of PlateUp, but you're not running a netcode itself. That is the netcode, but you don't even understand it. If we're talking about views, it's just the usage of the netcode. It's an abstraction layer on top of it. All right. So things that you can see and hear, so things like particle systems, game objects of the appliance and the player. So sounds that are played are all done in a view, right? Commands that you input are also written through the same network effectively, but they're slightly different, but they're still part of the same view idea, right? So there is one instance for each client. That's how the multiplayer works. But you can think of it all as the same view, right? On the host side, when you're doing the view itself, there's only one view, but it's distributed to everyone through the network, right? So you can think of it as one view is connected to one game object, to one entity, and we'll explain more about that. So when we refer to view, there's actually only one main view, all right? So an appliance is an appliance view, a player is a player view, a customer is a customer view, for example, right? It can have many subviews that describe little things like when you hold an item, where it's supposed to be, right? That's the item holder view. So player has item holder view, player cosmetic view, for example, the tool holder view, these kinds of things. So let me move on. This. So how is a view actually created from ECS, right? It's actually through this C requires view component. So when you have a C requires view component attached to any entity, there's an add new view system that takes control of it, right? It reads out any entity with C requires view. And using this C requires view, it actually distributes to two places, right? So it goes to a view itself, which does the instantiation of the game object. So for this, I won't be covering it. It's just the network and its view magic and whatnot, right? So in the next slide, I'll show you what it looks like when you do it as a mod, because we can't actually do it. We can't actually add a view prefab to the game like how the base game would. In this, it also creates a identifier, right? This identifier is sent out to the view to act as the identifier. So to act as a number that we can refer to it. And then this identifier is also passed to a ceiling view component where it's stored in this identifier here, right? So this C requires view is read by the system, and it creates an identifier that is stored in ceiling view, and this ceiling view is automatically attached to the entity that you attach the C requires view to. Right? So as mentioned in this part where it instantiates, as a mod, right? Oops. Do I have it here? Oh, I hid it. 1 second. Give me a moment. Let me unhide that slide. All right. Here. Right, so this is actually how we would do it as a harmony patch. So that's why we're not really covering it right now. You have to do it in your own time. If this is a harmony patch, if let's say we're writing code that is extending another piece of code, right? So this actually runs before we get a view type and we actually return a game object here. right? So I won't be covering in this, but I just know that there is some things behind the scenes you still to do in order to get the game object that you want. So for the view instance, right? After you create the game object, and the identifier is assigned, right? So the identifier actually points to this specific main view here, right? So whenever you send an update, it goes to this main view. How is this main view updated, right? It's actually through a view system. So if the view system contains is right here, it's actually ECS, right? So this ECS view system sends view data. What the view data is effectively a is what we call message pack object. So the message pack object contains what Nova mentioned earlier, right? Anything like integers, whatever. So just variables, basically. We'll cover how to write a view system later on. So for the view itself, it receives the view data that is sent by the view system, and it does whatever you need. So like update the game object by disabling components or updating the transform of a component, right? So for the view data itself, it is this is how it looks like. It's a message pack object. It contains variables in it. Um, there are two types of view data. One is called I view data. One is called I specific view data. I view data is used for the main view. I specific view data is used for the sub view. All right. The field is in message pack serializable, which you wouldn't really know what it means. Effectively, it can be used in a message pack. There are some classes you can use the message pack as well, but those classes itself must also be message pack objects in order for it to be used. Right. So how the update view works, right? Um, remember how we say that identifier is used to point to the main view. How this connection is done is through a view system. A view system sends out the view data, right, using its send update function. So it sends along some data that is into the player view, right, through a view router. Um, this view data, if it is an I view data, it ends here. The player view is updated using this, and that's the end of the chain. However, if a player view has multiple sub views, right, and you want to send a view, you want to send update, let's say a tool view, what you will need is an I specific view data because it is a sub view. Remember I mentioned that. So I specific, if the view data that is being sent is an I specific view data, the get relevant sub view method within the view data itself is used to determine what view it is. It's used to find the view. So it acts as this chain where everything goes through the main view and then it is distributed a sub view as necessary based on what the I specific view data finds. All right. So at this point, is there any question? If not, Nova, I'll pass it on to you to do the code for views.
Sounds good.
All right.
I have a basic example of a responsive main view that toggles all of the walls on the press of F5. Big thing to note with non-specific views is their view type. That is merely a random number I assumed to view type, which I did because this is a standalone. I do not know if there is a true convention with standalone views, but do be wary as there may be overlap. Kitchen Library has a method to do this relatively safely. basemod.add view type. I patch Harmony because I am patching to the local view router to grab the view game object as Milo described in their PowerPoint. It is to be noted that the game object will require the specified view attached to it. It will throw an exception elsewise. And so for the view itself. So for responsive views they have two different sets of data. One for sending and one for returning to submit. The response will require iResponse data, and that is what will be sent back to the host. The view data is the same as any other non-responsive view. And then the system. As Milo discussed, the linked view is a requirement, so we should make sure that it exists alongside our other requirements in the query. Fairly standard in terms of views until we get to the apply updates. Apply update to shorten it is basically us trying to grab a response from the view, and if so, retrieving that data. If we have that data, we can post our changes to ECS, as the client that will have the view is guaranteed to be the has state update determines whether that update should be posted out. This is just my own iteration for the specific problem where I determine if the disable walls is different. And if so, then I send back the value of disable walls. There's not a lot left, but before I go further, are there any questions as of now? Very well. Update data is a main part of any updatable object view and will take the data that is sent out and update the game object. In this case I'm not updating my own game object but rather the layout object. I will also mention in terms of Unity engine.input but uses sparingly. This is not the method that PlateUp uses by default but it works for our scenario to disable our walls on the single press of F5. I do not believe so as of yet. This is the base Unity key binding whereas PlateUp uses controllers. Another thing to be noted as to why you might do something like this is that this keybind will be available to all clients so anyone in my lobby could disable the walls. Absolutely, and there are many ways of going about such. One of the ways used natively is sending the player ID across to the view and then only enabling the view if that player has that ID. An example of such being the cosmetic mirror. The UI will only show up for you is what I'm thinking. That aspect is more on the system side. But to show that this does in fact work, I believe that is all unless anyone has any further questions. Or if you have anything you wish to clarify or add on, Milo.
Nope, I do not. So if anyone wants to stick around until like I think for the next like 5 minutes or more, it doesn't matter. So if you have any more ideas or something you want to clarify, right? So I'll be around then. So with respect to what you mentioned about the host, right? Checking. So there is actually a input source variable on the C player component. You can check that against, I forgot what it's called. I think it's default input source or something. So that is actually the same thing, right? So you will match those two. You can either send a input source from the host side to the client and check it against. If it's the same, that means the host is the one is the host view that is being updated, right? If it doesn't match, that means the client. So that kind of thing. Or you can do it on the you can do it checking on the ECS end also. It's the same thing. Let me look it up 1 second. It's called default input source. So it's spelled like that. Default inputs identifier, is it? Default inputs. Input source identifier. Input source identifier. There we go. So you just do this. There is this thing. Yep. So that's the one. You would check it against. I think you need to check the value of it, if I'm not wrong. I don't believe that is a integer value. It is not. For input source, right? Source identifier, default input source. Let me check it out. 1 second. Identifier.value. I believe it's this instead. You would check against this. So you either do the checking on the ECS end, matching the input source to this and determine if it's a host, or you can send this value. So input source identifier.value, send it along to the client. And on the client end, you check it against this value again. Yep, no problem. Okay. See you. Right, so we'll end it here for today. Tomorrow will be kitchen lib, and then the following day will be more library mods, and then we'll end off with Q&A.